Hi, in this video I want to go over some problems from chapters 9 and 10 and show you how you can work on the problems manually or especially if you want to use online calculators. So the first question, it says nationally patients who go to the emergency room wait an average of 5 hours to be admitted into the hospital. So that is a kind of claim. And any information about the claim must go on the null and alternative hypothesis. Now, it says, do patients at rural hospitals have a different waiting times? That's the exact claim. The 13 randomly selected patients who went to the emergency room at rural hospitals waited an average of 4.3 hours to be admitted into the hospital. And the standard deviation for these 13 patients was 2.3. So these sentences just give me the information about the sample. That's the number of sample size. So the sample size or n is 13. The average, the mean of sample or x bar is 4.3. And the standard deviation of a sample is 2.3. It is S. What can be computed at alpha equal 0.01 level of significance? Just repeat it. Okay. So first of all, when you read the question, you need to decide what type of test do we have based on the claim, based on the null and alternative hypothesis. So it's better to write the null and alternative first. So when I read these sentences again, it says patients go to the emergency room, wait an average of 5 hours. So the average for the null and alternative hypothesis is 5. But the claim says that two patients have a different waiting time. Different waiting time, that means the average is not equal 5. So we always put the equal sign for the alternative, so the null hypothesis must be equal 5. And you know that's your claim. The alternative right now is your claim. And what type of test do we use for average, for the mean? For mean, we have two cases, the z-test and the t-test. The z-test is for the time that we have information about the population standard deviation. And the t-test is when the population standard deviation is unknown. In this question, there is no information about the population standard deviation. And this sentence about the standard deviation is just for those 13 patients. That means that's for the sample, not for the population. So since the population standard deviation is unknown, that means we are going to use t-test. So we need to choose one of these, z-test or t-test. So for sure is the t-test for population mean. Then we need to find the null and alternative hypothesis. Okay. To write the null and alternative hypothesis, I put it here. So we need to choose mu. And we always choose equal sign for the null, mu equal to 5. So you choose mu. I'm showing you the answer, equal, and you just type 5. So for the next one, still we have mu, but not equal to 5. And if you see the correct answer, you see mu is not equal to 5, which is correct. Now it's asking us what type of test are we using? So for sure it's a t-test. So I'm going to choose t-test. Now I need to calculate the test statistic. So right now in this question, I only have one average, one sample. So that's a t-test for one sample. If you open the link for online calculator, you will see it says hypothesis test for a mean, for one mean, with a statistic. Yes, we choose this one because we don't have all the data values. We only have some statistics, some information. And if I choose this, he's asking me if sigma is noun or unknown. So for sure, sigma is unknown because I don't have any information about the population standard deviation. So S is 2.3, X bar, which is 4.3, and the sample size is 13. Mu, it's about the claim, which is 5. But for the claim, we said not equal to. So in this part, I need to choose not equal to. And then calculate. And it tells me that the t-value, the test statistic is negative 1.097. It's asking you to round to 3 decimal digits, which is negative 1.097. And if you see the answer, you will see that's exactly negative 1.097. And it's asking you about the p-value. And if you look at the p-value, p-value is 0.2940. And the correct answer is also 0.2940. You see, that's the correct answer. You just type the number. Now, after finding the p-value, it's time to compare the p-value with alpha. So the alpha is 0.01. And if you compare this p-value with alpha, you see that the p-value is greater than alpha. So you choose greater than. And whenever the p-value is greater than alpha, our decision should be fail to reject the null. And fail to reject the null, I'm showing you the correct answer that because I'm not going to submit the work. And when you fail to reject a null, that means you are kind of reject the alternative. When you reject the alternative, we have a weak evidence. So the evidence in this case is weak. Whenever your decision was supporting the claim or supporting the alternative, you say that's strong. But if it's when you fail to reject a null, that means you kind of reject the alternative or you don't have enough evidence to support the claim. That means those evidence is weak. And since the claim is on the alternative and you need to use the word support, but you don't have enough evidence to support the claim, that's right? So you support the null. And you can say our conclusion is that for patients who go to the emergency room, the average waiting time is equal to 5 hours because the null hypothesis is equal to. And you see that's the correct answer. Okay, let's move on to the next question. So in the next question, he says, it's asking that do a student perform the same when they take an exam alone as when they take an exam in a classroom setting? And we have a table which shows that the grade of students when they took the test, one in a solitary room and another time in a room filled with other students. When I'm reading these sentences, it tells me that these results are coming from same people. Exam alone means that subject took the exam alone, and exam in classroom means the same person is taking the exam in a class with other students. Whenever you have two different samples, but each of those values are for same subjects, that means they are dependent sample because both of them are coming from same subject, those information. And for the claim, it says, do a student perform the same means the grade for the exam alone is equal to the grade for the exam in classroom, but we don't work with the grade. We usually work with the average or the proportion. Right now, we have information about the average grade. So that means we have information about the mean, mu, okay, mu1 and mu2. Mu1 is when they took the exam alone. Mu2 when they took the exam in classroom. And we want to see if they perform the same. And we usually put the equal sign for the null hypothesis. So for the alternative, we put not equal to. But I told you this is the dependent sample. And for dependent sample, we also use the notation mu sub d because we want to find the mean of differences. So when you read the question, based on the information that's given to you, choose that you need to choose mu1 and mu2, or you have to choose mu sub d. So let's look at this example. So in the first part, it says for this study, we should use, so for sure, t-tests for difference between two not independent. They are not independent. They are completely dependent. So t-test for difference between two dependent population mean. Yes. Then we need to choose the null and alternative hypothesis. But when you look at the options, your options are just mu1 and p1. For sure is not p1. So my only option is mu1. So it means that I need to use these mu1 and mu2. But if I had the option for mu sub d, I could choose this one as well. So for null and alternative hypothesis, I choose mu1 and mu2. For the null, we always put equal sign, and for the alternative, we put not equal sign. And you can see the answers, mu1 equal mu2, mu1 not equal to mu2. Now it's asking you, what's the test statistic? So you chose t-test. So for sure, that's a t-test. Now I need to find the t-test. Okay, to find the t-test, I need to open the online calculator to make it faster. But let's see which calculator do we have to use. Since we are going to use t-test for dependent population mean, okay? So if I go back to the list of online calculators, we have two samples and two dependent samples with data because we have a table of data. So I need to choose calculator number 20, two dependent samples with data, and I need to type all of the values over here for data 1 and data 2. These are my data 1. I hope I can copy and paste. I know in the exam you cannot copy paste. You need to just type all the numbers, but make sure when you are typing, just put a comma, no space between numbers. Okay, now it's time to copy the second sample. Okay, now we need to choose if it's less than, greater than, or not equal to. Since we chose not equal to for the alternative, we choose this one. Then it's asking you what's the confidence level. The confidence level is 1 minus alpha. When alpha is a 0.05, that means the confidence level is 0.9. Now I press calculate. And it tells me that the t-value is 4.7819. is round to, please enter this. Okay, never mind. Okay, here. Show your answer to 3 decimal places. So it should be 4.782. Let's see the answer. 4.782. Yes, that's exactly my answer. He's asking about the p-value. The p-value is 0.002. So the p-value is 0.002. And now we are comparing p-value with alpha. And you know that alpha is 0.05. And this number is less than alpha. Okay, so I need to choose less than or equal to. And then whenever p-value is less than alpha, we reject the null hypothesis. So our decision is reject the null. But the null is my claim because I want to see if the student perform the same. I know that's my claim. Okay, so when you reject the null, that means you reject the claim. Okay, when you reject the claim, so what type of evidence do we have? We have strong evidence because we are exactly rejecting the claim. Okay? So anytime you reject the claim or support the claim, you have evidence, the strong evidence. Otherwise, if you don't have enough evidence to support or reject, that's a weak evidence. So it says our conclusion is that the average score for students who take the test alone is, so you're rejecting the claim, so that means it's not equal to. That's right. Okay, let's move on to the next question. So the next question says, you wish to test the following claim at a significance level of alpha equal 0.02. For the contents of this problem, mu sub d shows mu2 minus mu1. Okay, when you read the question, remember that when it says mu sub d is equal to mu2 minus mu1, you need to remember that in the lecture, we said mu sub d is always mu1 minus mu2. So in this question, it's changing the order. It says mu2 minus mu1. So, and you need to be careful because you may need to change, the notation later when you are calculating the test statistic as well. Okay, it says where the first data set represent the pre-test and the second represent the post-test. And it mentioned also here that the difference means post minus pre. So the first data set, so right now we have mu sub d, which is mu2 minus mu1, which the first one is pre-test and the second one is post-test. And we want to, the alternative says that they must be not equal to 0. That's a claim because it says you want to test the alternative. So that means the alternative is your claim. It says you believe the population of difference score is normally distributed, but you do not know the standard deviation. So when you do not know the standard deviation, that means that's the t-test. You obtain pre-test and post-test samples for n equal 88 subject. The average difference, or d bar, is equal to 10.8. And the standard deviation, it's the standard deviation of the sample, is 36.1. What is the critical value for these tests? So you know that the critical value cannot be found by online calculator. You just need to use TI calculators or tables, the Z table or T table. So now, to find the critical value, I know that's a t-test. So I need to look at t-table. So if I look at t-table, just clear this. lines. Okay. If I want to use the t-test, I need to know the alpha for one tail or two tail and the degrees of freedom. Since the test, the alternative is not equal to, that means you have a two-tail test. So we have a two-tail test, and based on the question, the alpha for these two-tail tests is 0.02. And the degrees of freedom, which is n minus 1, is 81, 8 minus 1, which is 87. Now go back to the t-table and look for these numbers. So two-tail 0.02 is this one, and degrees of freedom is 87, but we don't have 87, we just have 80. And just let's find the number for 80. And I think the answer should be this. So the critical value should be 2.374. 2.374. But you know, whenever we have two-tail test, that means we have two critical values, a positive and a negative. That's why you see that out of the box we have a plus and minus. So you don't have to put a plus or minus for the number that you put in the box. Just type in the number. But the number I have to put, based on the information that I got from the table, 2.374. Yeah, you see, that's the correct answer. We may, um, in this case, since we don't have the exact 87 on the table, our answer from the actual correct answer might be a little different, but that's okay. If we are close enough, it probably mark it correct, or even if it mark it wrong, when I am checking the answer after the exam, I will fix your grade. So don't worry about that one. I understand that the table values are slightly different with the actual values. So I don't expect you to have the exact value, but if it's close enough, like what you see here from the table, I have 2.374, but the correct answer is 2.370. But it's close enough, so it's fine. And now it's asking you to find the test statistic. To find the test statistic, you may need to use online calculator. But if you look at the list of online calculator, since in this case we have dependent sample because of mu sub d. For dependent sample, we only have a calculator with data, which asks us to type in data. But in this question, we don't have any data, so we can't use an online calculator. So I only need to use the formula from the lecture notes. And the formula is that the t-value is equal to d bar minus mu sub d over standard deviation of the difference over the square root of n. You just type in these numbers. The d bar is 10.8 minus mu sub d is always 0. S sub d, which is 36.1, divided by the square root of 88. Okay. Since you have a fraction on a denominator of another fraction, you can just multiply both sides by the root 88 to get rid of this case if you want to, do it manually. So what you want to type this in the calculator, you just need to type this one, which is much easier to type in a fraction above another fraction and make the calculator give us a wrong answer. Because calculator always follow the order operation. And if you don't type the numbers based on the order operation, you don't give the right answer. So I type in 10.8 times square root of 88 and divided by 36.1. And the answer that I got is 2.8064. And it says round to 3, which is 2.806. And let's see the answer. Oh, yeah, that's 2.806. That's the correct answer. Just use the formula. It's not that much hard. Now, when now it's asking you if this test statistic falls in the rejection region. So since we had a two-tailed test, for a two-tailed test, we always have two critical values. That's why we have a plus and minus. So we have plus 2.37 and negative 2.37. And I know the rejection region are these areas. And the answer that I got is, and the rejection region is any number that's less than negative 2.37 and greater than 2.37. And my answer here is actually greater than 2.37. So yes, it is in the rejection, critical region. Yes, it's in the critical region. And if it's in the critical region, that means you need to reject the null. And if you reject the null, that means you're rejecting the equal sign. But the claim is on the alternative. When you reject the null, that means you support the alternative. You support the claim. Now, when you read these options for your conclusion, you say, there is enough evidence to support the claim. Let's see which one has the word. There is sufficient evidence of warrant rejection of the claim. No, we're not rejecting the claim. There is not sufficient evidence to reject the claim. There is not sufficient sample to support the claim. So let me just make sure that claim is on the alternative. Yes, not equal to. So the sample data support the claim that the mean difference of post-test from the pre-test is not equal to 0. It should be this one. Yes, that's correct. Okay. Let me just erase this and move on to the next question. Next question, it says, test the claim that the proportion of men who own cats is larger than 90% at the 10% significance level. At the 10% significance level. Okay. When it says, the claim says the proportion. Proportion tells you that you need to use P. And the claim says that the proportion of men who own cats is larger than 90%. That's the claim. Where do we put this claim? Since there is only greater than, we put it in alternative. So for the null, we only put less than or equal to. So which one is my option? I think it's this one. Okay, let's check. Yes. Now, it's asking you what type of test do we have. To find the type of test, we only look at the alternative. The alternative is greater than. Greater than means a right tail test. So we have a right tail test. Yes. Now it says, if we have a sample of 100 and 97% own cats, that means the proportion of sample or p hat is 0.97. Which it means Q hat is 1 minus 0.97, which is 0.03. Now you want to test the statistic. Okay, you can write the formula and use the formula to find the test statistic, or you can use online calculator. So in this example, the problem is talking about the proportion, and we only have one sample. So when you open the link of all online calculator, you need to use the hypothesis test for one proportion, which is number 16. Okay? When you open the calculator, it's asking you what's the sample size, which is 100. What's the x? X means is coming from the p hat. So you know in this question, the x is not given to you. You only have the p hat. But you know that p hat is always equal to x over n. If in the question the x is not given to you, you just calculate it. P hat is 0.97. I don't know the x, but I know the n is 100. Okay, to find the x, you need to multiply both sides by 100. And it gives you that the x must be equal to 100 times 0.97, which is 97. So the x is 97. So now when you go to the online calculator, instead of x, you just put 97. P sub 0 means the claim. For the claim, we have 0.90. So we just type 0.90. And it's asking you to choose the correct notation for the claim. The claim says greater than. And now we calculate. And you know, for proportion, we always use z-table. If it's asking about the critical value, you use z-table. If it's asking you to find the test statistic, you're finding the z again. So now the z is 2.333, and the correct answer is 2.333. Yes. You don't need to write all those threes because it's asking you to round to 2 decimal places. And the critical value, okay, the critical value is coming from the z-table. What type of test do we have? We have a right-tail test. When we have a right-tail test, that means I have one critical value here, and the rejection region is the area to the right. But to find the critical value, I know the alpha is the area to the right, and alpha is 0.10. So I need to look at the z-table to find the critical value. But for the z-table, you know that there are only two options. When you look at every time you look at z-table, you must have the z value to find the area under the curve, which is on the body of the z-table, or you need to have the area from the body to find the critical value or the z value. Right now in this example, you have the area. Area to the right is 0.10, which it means the area to the left is 0.90. Don't forget that all of these areas on this table are the left area. So if the area to the left is 0.90, you look at the body of the table to find 0.90. 0.90 is or closest number that you can find to 0.90. Let me see. 0.90. I think this is the closest number that I can find. Because the other one is 147 more than that, but this one is just about 27, maybe less. So it's 1.28. So I think the critical value must be 1.28. Yes, that's correct. 1.28. As long as you have the 1.28, you have the correct answer. I don't care about the rest of the digits because the question also says rounded to 2 decimal places. Now, when you have 1.28 as the critical value, that means any number greater than that must be rejected. And your test statistic is greater than that. That means you need to reject a null. Yes. You can also use the p-value. From the p-value that you got here, you can compare this p-value with alpha, and since alpha is 0.10 and this number is less than alpha, again your decision is rejecting the null. So you can use the p-value to make your decision, or you can use the rejection region to make your decision. Okay, I'm going to erase the board and start the next question, which is the last question. Okay. Okay. The next question says, do political science classes require more writing than history classes? Okay, that's a claim. Now it says, The 46 randomly selected political science class assigned an average. So for the political science class, we have a sample of 46, and the average, the mean of this group is 12.4, and the standard deviation for these 46 classes, which means the standard deviation of the sample, is 6 pages. And for the history class, the sample size is 42, the average or the mean is 10.7, and the standard deviation for these 42 classes is 4.5. When it says the standard deviation for these 42 classes, that means that's just for the sample. So that's S, not. So no information about the population standard deviation is given to us. Okay? And now it's asking, do political science classes require more writing in average? So if we have the average for political science classes and the average for history classes, we want to see if the political science classes requires more writing. Is the average for political science more than the average of the history class? And where do we put the greater than? In the alternative. So for the null, you just put equal sign. But instead of political science and history, you can use mu1 and mu2. So it's n1, x1, s1, n2, x2, s2. So mu1 and mu2. Mu1 equal to mu2. So since no information is given to us about the population standard deviation, we're going to use a t-test. But t-test for difference between these are two completely independent population, because one class is political science, one class history, completely independent. So we're going to use t-test for difference between two independent population. And I need to choose mu1 and mu2 for the null and alternative. And as I said, for the null, we always put equal sign. For the alternative, we put greater than. You can see the correct answers here. Now it's asking what type of test are you using? So for sure, we're using t-test. And now we need to find the test statistic. I'm going to use the online calculator. Okay, this time I have two independent samples. So two independent sample with a statistic or data. We don't have data, we only have a statistic. So we need to type in the first sample size, so that which is 46. The first sample mean is 12.4, and the first sample standard deviation is 6. The second sample is 42, 10.7, and 4.5. Just type in all the information from two samples. And I need to choose the correct notation for the claim. The claim says greater than. I need to choose greater than, because if you don't choose the correct notation, your answer would be wrong. And the confidence level, which is the alpha, based on the alpha. So if I go back, the alpha is 0.05, which means the confidence level is 0.95. Now, if I press the calculate, the test statistic is 1.5116. 1.5116, if you round it to 3, gives you 1, 2. It's asking about the p-value rounded to 4 decimal place. P-value rounded to 4, it's 0.0672. 0.0672, yeah. And this p-value is greater than alpha, because alpha was 0.05, but the p-value is 0.06, so it's greater than. And anytime p-value is greater than, we need to reject, we fail to reject the null. If it's less than, we reject. Greater than, fail to reject. And when you fail to reject the null, that means you you don't have enough evidence to support the claim. So that means the evidence in this case are weak. So you cannot support the claim. If you don't support the claim, so that's your conclusion. So your conclusion says that the amount of writing required for political science class is equal to the amount required to the history class, because we assume equal sign for the null hypothesis. So I hope that helps, and let me know if you have any other questions.